Hello everyone, welcome to the course Climate Change and Extreme Events. Today is the lecture 5. In this lecture, we will talk about what is exactly extreme precipitation, floods, droughts and water cycle impacts. In the previous lecture, we have talked about primarily the temperature extremes. We have discussed about what is exactly heat waves, what is exactly cold spells and cold waves, then their characteristics and their governing mechanism. Then we have also briefly talked about what is their impacts on different parts of the world, as well as how the climate change are exaggerating these temperature extremes across all different countries across the world. So today's lecture is primarily focused upon the extreme precipitation events and how these extreme precipitation events can lead to more floodings or more drought kind of conditions or changes in the overall water cycle across different parts of the world. So in this particular lecture, we will talk about what is exactly extreme precipitation it forms. Then we will talk about the causes of floods and droughts. Then we will also talk about what is the impacts of precipitation extremes on the water cycle, and then we will in between we will also discuss some of the results which has been observed by various global studies on their trends, projections for extreme precipitation event under different climate change scenarios like that. So when you talk about extreme precipitation event, it is basically refers to the unusually intense rainfall events that significantly exceed the normal levels for a specific location and the time for some certain duration of the time like that. So basically this is a kind of a threshold we draw where precipitation events increases above that threshold, that can be considered as a extreme precipitation events, or where we receive a huge amount of rainfall or snowfall in a certain region, precipitation in that is considered to be as an extreme precipitation event like that. There are several methods which we can classify whether these particular precipitation events are extreme events or not. So there is a statistical threshold method where whatever the amount of precipitation we are receiving, if we draw a probability density function or let us say a normal histogram of the data, we can also calculate what is the 90th and 95th percentile of the rainfall of one particular location, or where this is happening, or any area of interest where we are looking at. So this 90th and 95th percentile threshold basically refers to be a threshold of extreme precipitation event. If the precipitation events are increases certain millimeter after this threshold, which can be considered as extreme precipitation events like that. There is a we can also draw threshold like a number magnitude, which is like 50 mm per day or 150 mm per day like that. If any precipitation events are crossing this particular threshold, can be considered as extreme precipitation events for that particular regions like that. So these events are generally short lived, which means they occurs for a very brief period of time, very short period where few days or something like that, or few hours, which can cause a very severe flooding or landslide in some regions, or several types of water related hazards like that. Therefore their impacts on water cycle is very important and very crucial to understand if you are planning for some sort of mitigation or sustainable measures. So this is primarily the extreme precipitation or when the precipitation events are crossing above certain thresholds, it is also likely possible that we have extreme no rainfall days, which is also considered to be extreme conditions of rainfall, where the rainfall amounts are very low, and that can also exaggerate in the form of, let us say, several different types of droughts. So, on the one hand, extreme precipitation, if crossing certain thresholds, are creating floods, flash floods, riverine floods or pluvial floods like that. On the other hand, if we have no rainfall at all for very extended period of time, it can also create some sort of other problems, other hydrological hazards, which can be considered as, let us say, drought events, meteorological droughts, agricultural droughts, hydrological droughts, etc. How these extreme events are influenced? Primarily, these extreme events are influenced by the atmospheric moisture availability and several types of weather system, particularly, let us say, cyclones, monsoon. These are the system which can influence the occurrences of extreme precipitation events in one particular region. There are also global phenomena of climate patterns, for example, ENSO events, which is called El Nino or La Nina. This can also be a kind of influencing factor which can increase the effect of extreme precipitation in certain regions like that. Overall, if you talk about climate change impact, warming temperature increases the atmospheric moisture holding capacity, and therefore it leads to more frequent and more intense extreme precipitation events globally. That is the one-on-one correlation between when you have more temperature in the atmosphere because of the greenhouse gases emission and all that, the moisture capacity will increase, and therefore it leads to more frequent occurrences of different types of hydrological extremes spatially. So, these are the general description about extreme precipitation events across and their definitions like that. If you talk about globally, so I have taken multiple figures and multiple case studies, global studies using the IPCC AR6. This is annual report 6 of IPCC. Here we basically we will use those results which has been already produced by IPCC to basically elaborate what is exactly different forms of extreme precipitation which can influence our day-to-day life or hydrometeorological condition of one place or another place like that. So, this is a one example where we are talking about the extreme precipitation occurrences across and their trends across globally. So, there are several regions where we see that there is a negative trends or positive trends, and there are several regions where we also see that there is a negative trends, which means in the historical time period these trends are continuing, which means extreme precipitation events, if we are talking about one day maximum rainfall amount, how much amount we receive in one day has been directly continuously increasing. There are lots of places in the world which we have observed a significant rise of these kind of events like that. On the other hand, there is a negative trend as well we have reported, which is also suggesting that there are many places where the annual maximum precipitation events are also decreasing, which is basically can be considered as a reduced vulnerability or risk of extreme precipitation events in those regions like that. If we see the distribution of extreme precipitation events across globally, we can see that there are several regions where we have significant positive changes in the extreme precipitation event. There are some region also shows there are negative changes in the precipitation events like that. Similarly, if you see there are different regions, for example, South America, North America, Europe, Africa, Asia and Australia, here also shows the two different types of nature of these extreme precipitation variability. One is suggesting that there are few regions where these events are increasing, there are few regions where these events are also decreasing. So, where these are increasing, which is also basically considered to be can attribute the conditions of, let us say, flooding hazards or extreme floodings or flash floodings, or there are several types of water related hazards like that. When it is decreasing like that, it can be attributed to less water availability in those areas and can lead to some sort of drought events or water scarcity kind of conditions in those areas as well. If we talk about Indian region particularly, so all of the central Indian region and several neighboring regions like here, which is this figure is depicting, is suggesting that there is a significant increment of extreme events. Also, if you look at the Western Ghat and northeastern region as well, there is an increasing amount of very heavy rainfall events. If you computed by, let us say, 1951 to 2015 like that. This figure also suggests that there are several places in India as well where we have seen a significant rise in the extreme precipitation event in the historical time period. In the future part of the period, based on the IPCC-AR6 report, it is also suggesting that when you increase the temperature globally by 1 degree, 2 degree, 3 degree and 4 degree, the likelihood of occurrences of extreme events also increases, as we already discussed that the amount of water carrying capacity of atmosphere also increases by 1 degree of increase in the global temperature, and therefore this also leads to increment of the increase in the events intensity and occurrences of extreme events across the world as well. So, in this bar plot, in this box plot, we can directly see that the 10-year and 50-year events has been significantly increased. If you compare to, let us say, 4 degree scenario, here the median value is around close to between 30 or 35% like that, which means the 10-year return period and 50-year return period is likely to be increased by 30 and more than 30% in the 4 degree rise in the global temperature like that. There is a spatial distribution of these annual maximum precipitation change across whole world. For example, this is 1.5 degree, 2 degree and 4 degree. Here we see that in 1.5 degree, most of the regions which are located in the equator portion, 0 degree and nearby those region latitude, here we are seeing that there is a significant change in the extreme maximum daily precipitation magnitude across. As we increase the temperature of globally, we can also see the region which are affected by increasing amount of precipitation also increases, and at 4 degree global warming scenario, we have observed that there is a significant rise in the the extreme precipitation or maximum daily precipitation event across whole globe. Most of the regions are covered by very increment of increasing amount of and these rainfall amount across the world like that. So, these figures are suggesting that when you increase the the climate change or the global warming, or because of the greenhouse gases the global warming is increasing or something like that, this will lead to your occurrences of more frequent extreme events across whole world, and that can lead to different types of water related hazards. There are few regions where we have observed that there is a significant rise in extreme precipitation events, which is basically suggesting that those regions are likely to be affected by more catastrophic floods or extreme floods events like that. There are few regions which is also observed that the extreme precipitation events are continuously decreasing or statistically decreasing, which means those regions are likely to be influenced by low availability of water or water scarcity or drought like conditions in the future scenarios as well. So, moving forward, now we will talk about what is the implications of, let us say, changes in the extreme precipitation events on different types of hydrological processes, primarily the floods, droughts and overall water cycle impacts. So, what is exactly floods? Floods is generally defined as when we receive a very extreme amount of rainfall at one certain place, there are two flooding processes which can influence or propagate the flooding conditions in that particular region. When the intensity of rainfall is that very high and the infiltration capacity of that region is very not is slightly lower than the intensity of rainfall, in that scenario it is possible that the flooding can occur because ground is already saturated because of the not saturated, but the infiltration is not that much rate compared to the precipitation amount, and therefore it can lead to intensity driven runoff condition or flooding condition in that particular region. That is primarily seen in those areas where we have high intensity sudden downpour or sudden rainfall, extreme rainfall events happens in some certain regions. There is another condition when the ground surface are completely saturated because of the long duration rainfall event, and subsequently if the extreme events occurs, or let us say any high magnitude events rainfall occurs, it can also create some sort of flooding problems, which is basically called saturation driven runoff or flooding in that particular regions like that. So these are the two governing mechanism which basically dominates the flooding parts in different parts of the world. The floods generally can be defined into 5 different categories. There is a one flood which is called, let us say, riverine floods, which is caused by prolonged rainfall or snow melt or exceeding river capacity. Suppose you have a river channel and that river channel has a certain amount of capacity which can hold the water, and suddenly if a very huge amount of water comes and the water capacities of the channel surpasses and it cannot hold that much amount of water, what will happen? The extra amount of water will be spill over to the floodplain or neighboring regions like that, and that can create flooding issues in those regions like that. The second flood category is called flash floods, where we have just explained that this is the intensity driven runoff, where very intense rainfall event occurs and that can create the flooding in very short period of time. There is a third flood event is called coastal flooding, which is a result of storm surges, sea level rise or tsunamis. At the same time, we have a very huge amount of extreme rainfall events at that particular region. Sometimes these all the floods can be also considered as the compound flooding conditions, where there is a high level of sea level rise or storm surges or tsunamis. At the same time, we have a very huge amount of precipitation events occurs in the same regions like that. That can propagate the effect, amplify the effect, and that can create coastal flooding in those regions like that. There is urban flooding, which is basically triggered by inadequate drainage system in densely populated areas. We have heard about multiple stories of different cities which are affected by urban flooding problems because of the poor drainage system, unsustainable development of different types of urban settlements like that, and therefore that can propagate or create the problems of urban flooding in those regions like that. There is a pluvial flood also when can define, which can basically defined as surface water accumulates due to heavy rainfall independent of river or coastlines. That can also primarily driven by the heavy rainfall or prolonged rainfall events in a certain regions like that. So these are the general 5 categories of floods where we can divide it and then we can understand. So initially we had discussed about as the temperature rises, the warming the moisture holding capacity of atmosphere also rises, and therefore it leads to more heavier rainfall or heavier snowfall in a certain region that can create more flooding problems in a regions. So this figure is basically depicting that mechanism of when we increase the temperature and therefore moisture level will also rise, that will basically changes the heavy rainfall event, also the precipitation in the form of snow as well, and that can create some types of flooding problems in different parts of the world as well. If you look at this is the figure which is a climate model projection of annual maximum stream flow in 21st century. Here if you can look at, there are several regions particularly located in the African continent, also the Indian regions as well, and there are several countries in southeastern countries like that, or South America or Australia like that. Most of the regions are showing that there is an increasing projection of the flooding in these particular regions like that. Therefore, these regions are susceptible to rise in the flood events in the future projections or future conditions as well. So, there are primarily two particular governing mechanism which can derive the flooding potential of a certain region. One is your climate change, which is we have just discussed. There is another processes which is human made effect. Suppose we change the land use, land cover conditions, urban settlements, or if you modify the land use in some other way, that can basically lead to some sort of flooding problems in that regions like that. So, here let us say the climate variables are when you have let us say higher rainfall or greater storm surges or low like that, or we have more persistent wettest event or rainfall event, and then we have also interaction of the cloud microphysics which can further increases the effect of rainfall precipitation in certain region. That basically fuels more moisture conditions, and therefore, it can lead to heavier rainfall or increased flood severity. It is also possible that because of the temperature rise, the glacier and snow will also melt, and therefore, it will saturate the ground cover a little bit earlier, and therefore, it can also create some sort of significant problems in floodings as well. So there is also here the stronger spring melt and increasing the river flow, and therefore, in conjunction with let us say if you have higher rainfall events can create more flooding problems like that. As we have already discussed, worsening of the coastal flooding because of the combined sea level rise and heavier rainfall can also lead to severe flooding events in a certain region. There are some human factors also. Let us say if we increase the water uses, that basically reduces the water flow, river flow, that can decreases the river ability to flood in certain region. But let us say if you have urbanization in a certain region, that can lead to more flash flooding or increased rain runoff event in those regions like that. Or maybe if you have let us say more greater capacity of drier soil and more when we have more heavy rainfall occurs at that particular soil, can also create a very huge amount of flood events in those regions like that. So, there are some sort of climate drivers, there are anthropogenic drivers also, which can further amplify the effect of the floodings in different regions, and that can increase the risk of flood related hazards in those regions like that. Now, we will talk about another types of hydrological extremes which are linked to your precipitation deficiencies or low amount of precipitation in certain region. That is called drought event, where we have primarily the low availability of water for different purposes, and therefore, it can create very significant damage to the socio-economic conditions. In comparison to the flood conditions, droughts are more prolonged period of hydrological events driven by different types of hydrometeorological activities, and that can basically affect the regional biodiversity as well as socio-economic conditions. So, we can define the droughts into 5 different categories. First is called the meteorological drought conditions, which is defined as the significant reduction in the precipitation compared to the historical average of the region. Suppose you know that in a one particular region, let us say 1000 mm is the normal range of rainfall which generally occurs, but in a one particular year in that particular place, let us say we receive only 500 or 600 mm rainfall, almost 40% decrease or 50% decrease of the rainfall like that. In that scenario, that district or that place can be considered as a meteorological drought affected, because the rainfall has been significantly depleted because of certain atmospheric conditions or low monsoon activity or something like that. There is another type of drought impact is called agricultural drought, where the soil moisture levels are insufficient to support crop growth and agricultural activities. In that conditions, the soil moisture is not in the sufficient level, so that water can the plants can extract the water from the soil, and therefore that can impact overall the crop yield or biodiversity in a certain regions. That is considered as agricultural drought. There is a third category is called hydrological drought, where the water has been significantly reduced. Water availability in rivers, particularly let us say reservoirs, lakes, groundwater system has been significantly depleted, and therefore it can create a kind of a water scarcity or water scarce problem in certain region. That can be considered as hydrological drought situations. There is a fourth type of drought is called socio-economic drought. Let us say if you have a very little amount of rainfall in that particular year, and therefore the water, surface water and groundwater system has been significantly depleted, and as a result the soil moisture has been also declined in that particular region. What will happen, which means the availability of water has been already reduced because of the drought occurrences, and the crop yield has been also affected, which will directly impact your food productions and overall kind of malnutrition kind of conditions or socio-economic impacts in those part of regions like that. So therefore this is called socio-economic drought conditions in that particular region. There is a fifth type is called ecological or environmental drought, which basically affects the ecosystem and biodiversities due to prolonged water shortage, and that can create a severe loss of forested region or biodiversities, and because of multiple different hazards can be also be linked. Therefore, these are the different types of droughts which can basically we can classify under different categories. So as we discussed, like floods, there are several governing factors in the case of droughts as well. The first driver is precipitation. Of course, when we have lower amount of precipitation, that can lead to some sort of meteorological drought condition, and that can lead to multiple different types of drought stages like that. At the same time, let us say if you have more solar radiations and if you have more temperature rise, that can also, and also let us say if you have more wind activity, that can also lead to loss of more water from the surface and the soil moisture from the ground as well. Therefore, that will basically decreases whatever the availability of water in stream flow, groundwater system and soil moisture because of the evaporation process, evapotranspiration process, or different types of hydrological mechanism which basically leads to decrement of surface and groundwater and soil moisture reserves in different parts of the world. When you have a depleted amount of precipitation, that can be considered as the meteorological drought conditions because rainfall has been significantly depleted. But when you have stream flow and groundwater has been depleted, which can be considered as a hydrological drought, which we have already discussed like that. And when we have, let us say, soil moisture depletion, which can lead to kind of agricultural and ecological droughts. So if you compare, let us say, meteorological and hydrological drought, which can create environmental drought conditions, and if you can combine all these droughts, which can create a socio-economic drought conditions for a particular place like that. So this is the overall the process interpretation of drought mechanism, how the different factors, meteorological factors are governs the impact of, let's say, on drought conditions in different part of the world like that. This is the one example of different types of drought, hazard, vulnerability, exposure and risk across different countries across the world. So, here the drought hazard are simply defined as the severity of, let us say, the drought events in a certain region. Drought exposure is generally how many people are exposed to that particular drought events. Drought vulnerability is what is the degree of affected by drought conditions in that particular region. And drought risk is basically generally defined as the combination of hazard, exposure and vulnerability. So, if you, in a very simple terminology, hazard can be defined as, let us say, if you are talking about flood hazard, if we can map, let us say, a region near a river where we will say, okay, this is the 100-year written period floods region where this area can be inundated. So, that is the flood hazards, or those regions are considered to be flood hazardous regions, or where flood can occur. Flood exposure is, let us say, if somebody starts building some house in those particular region which is already marked as 100-year written period floods region, that can be considered as a flood exposure zone, where those people are exposed to that kind of extreme conditions. Flood vulnerability or vulnerability can be defined as, let us say, if you have poor quality material of that house building activity in those regions, or whatever we have constructed there is not up to the mark, or let us say it will not it will be affected by 100-year written period flood like that. That is called flood vulnerability or vulnerability in the sense. And the risk is generally associated with your hazard, what is the level of hazard, what is the level of exposure there, and what is the level of vulnerability there. If you combine all these factors, we can calculate the risk associated with the different types of extreme precipitation events and hydrological events across the world. Here, if you look at this map is showing the drought hazard map for different countries. This is drought exposure map, and then this is drought vulnerability and the risk map. If you compare, let us say, the drought hazard map, if you see at Indian region, here the hazard is not that much, but if you look at the drought risk is very high, which means the exposure and vulnerability of Indian region is very high. Therefore, the risk has been significantly higher than other regions compared to the world like that. For example, if you talk about, let us say, this Australian region, the exposure is very low and the vulnerability is also very low, and therefore, the risk is not that much high even though the hazard is very high. So, these are the balance we have to understand when we are making some sort of sustainable, different types of management for managing these kind of extreme conditions for that particular regions like that. So, this is a kind of a map which generally shows that what is the projection of changes in the likelihood of extreme drought events across the world. Almost all the increasing temperature scenarios, it is suggesting that many regions are likely to be affected by droughts activity. There are several regions where the drought intensities and the agricultural drought years, likelihood of these extreme agricultural drought years has been significantly increased, particularly, let us say, South American countries and all of the your higher latitude countries like that. European region are also affected by severe drought kinds of activities in the future climatic conditions as well. This is the plots which is shows that the distribution of these drought anomalies across different parts of the world. Here it is suggesting that in the historical period it was little bit more wetter condition. However, as you increases the temperature, the conditions become more drier, which means the occurrences of droughts has been increased, and therefore, that is going to affect more drought kind of risk in those regions, and therefore it can affect the overall socioeconomic conditions. So, this is, we have talked about extreme precipitation, then floods, then droughts. This is the another example of overall impacts on the water cycle. So, there are several key processes are listed here in the right side. There are several drivers which are also listed here in the left side. Suppose if you change the urban cover, it will lead to increase amount of urban precipitation, therefore urban runoff or flooding part, reduces the infiltration, let us say reduces the groundwater storage, increases the surface evaporation and reduces the plant transpiration because of the changes in the land use land cover characteristics. Suppose if you change, let us say soil moisture condition, it leads to affect the precipitation pattern, and it will also affect your overall surface evaporation or transpiration evaporation process in a certain regions like that. If you change the aerosol content or dynamics in a certain region, it will surely affect the precipitation pattern, therefore it will affect the overall impact on water cycle or let us say condition in certain region. If you have over water extraction, that will lead to more depletion of the groundwater resource, surface water evaporations like that. And let us say if you have changes the vegetation cover because of the land use land cover change, it will lead to more significant differences in the precipitation event, therefore more runoff or infiltration has been decreased like that. So, these are all these activities will happen when you change the vegetation cover in a certain region. Of course, when you increases the global warming, it will lead to multiple different hazards. For example, changes the water cycle. For example, precipitation pattern will change, surface evaporation pattern will change, and the plant transpiration will also affect it. Therefore, these different processes tells about how the water cycle will be changed if you change these types of different factors, and that can lead to more extreme precipitation, extreme flooding condition, extreme drought condition in a certain regions like that. So, overall in this particular lecture we have talked about what is exactly extreme precipitation events, what is their frequency and severity in the historical and future projection scenarios. Then we have talked about different types of extreme precipitation linked events, for example, higher threshold or higher magnitude side flood events where we have very extreme rainfall that can link to extreme flooding conditions, different types of flooding conditions in different parts of the world. On the other hand, when you have lower amount of rainfall or no rainfall at all for very prolonged period of time, that can basically lead to a drought types of situations which can create multiple different socioeconomic losses, for example, biodiversity loss, crop yield loss, or let us say loss of water availability like that, that can affect overall the socioeconomic condition in one certain regions like that. Then we have also talked about changes in the climatic conditions because of the global warming or anthropogenic impact, the water cycle will also be affected, and that can lead to changes in the different types of water cycle processes which can lead to multiple water or extreme precipitation linked hazard across the different parts of the world like that. So, this is the overall summary of this particular lecture. In the next lecture we will talk about tropical cyclones, storms and associated weather events, and we will discuss these types of different extreme events in the context of climate change and human activities like that. Thank you so much for your attention.